Can you guys get the lights, please? I'm gonna see how much I can get done today.
I went to England. That's when I saw the place name a lot. I mean, that's my room up there. Holy grail. Because I was recording my field. I forget. You're recording?
All right, guys. First of all, what I want you guys to do is there's two different worksheets. Make sure it says proportional tables at the top. It's the one that it says it has a bunch of just tables. There's no graphs on it. That's the one I want you to look at first. What?
Is it right here?
For now, yes. Okay. I have about 15 minutes. Whatever we don't finish of this lesson, you're going to be required to obviously look at the video tonight, okay? And I believe I should be able to explain it in 15 minutes, but if you have questions, obviously that's where we'll come back and talk about it tomorrow, especially for those people that are going to have to watch the video. They're going to probably get some questions anyway, okay? So, where are we going to? Where are we going to next? Well, obviously we talked about ratios last week. We talked about complex ratios. We talked about unit rates. So this week what we're going to do is we're going to take that and we're going to actually use some ratio tables to determine proportionality. And that's where all of this, ratios and proportionality, comes into play, and then they create graphs. And this is your first function family that you're going to witness is during this week. Okay? So you're going to actually have your first glimpse of your first graph of where proportionality shows. So the first thing we're going to take care of is how do you tell if a table is proportional? First of all, does anybody know what proportional actually means? Like if I say two things are proportional, do you even know what it means? Nick?
Way the same.
I like the S word. I'm talking not the naughty S word. I'm talking about the word you said, same. Okay, they're the same. What's another word for same? Two things are proportionate. They are equal. Another E word. It means equal. Equivalent. There you go. So if we want to see if the table is proportional or not, that's the first thing. Before you leave class by Friday, I want you, this is your goal this week, is to figure out if I give you any table, can you tell me if it's proportional or not? Okay? Can you stop? That's annoying. And also, not only a table is proportional, I want you to be able to just look at a graph and say yes or no if a graph is proportional. So there's two things before the end of this week that is my goal for your class, is to make sure, and actually three things. Ready? To write an equation if it is proportional. Okay, so there's three things that hopefully by the end of the week you'll be experts at. Okay? I'm hoping. If we're trying to master that, that's good. So here we go. So first of all, we just talked about what is a proportional. Obviously, what does proportional mean? It means when two ratios are equivalent. So I'm going to bring that up here. You don't have this. I have this. But basically, what I'm trying to ask you guys to do is if, obviously this is not a table, but if I gave you a table, it'd be the same kind of thing, where you first have to find the units of pattern, okay? You also have to find first and second ratio. You have to be able to simplify. You guys know how to simplify? Okay, those are some requirements you're going to have to do. I don't think I have to do this slide. I usually do this with the other classes, but can we just go right to the table, you think?
Yeah.
I think. I kind of do like a little situation first before we go to tables, but I think I can skip this slide. So let's go to this slide. I think it's on the back side. It should be on the back side of your paper. You should see this. You guys see it? Okay. I know it says table 5, but guess what? I think it's better off if I do it this way. So basically, to determine if a table is proportional, first of all, in a table of values, have you guys ever seen a table of values like this with X and Y's in them?
Yes.
Okay. These actually are coordinate plane. These are actually coordinates of a graph. Okay, you have X coordinates and Y coordinates if you're going to graph something. So I call these T charts, tables. You guys see the T? Yeah. This is how I see the T. See that? I call them T charts. Okay. So this X goes with this Y, this x of 3 goes with this y. And basically what you're going to do is you're going to create a ratio. All ratios have to be in this format, okay? And what you have to do is, if you notice, these are the first pair of x and y, this is the second pair, and this is the third pair. Now watch, y to x. You guys see how it says 4 to 2? You guys agree that this 4 is to 2 x? So they write that as in that order of ratio. So y to x, 4 to 2. Then they do the next one, 6 to 3 here. And then they do 10 to 5, which is this one right here. And if you notice, what do they all simplify as? 2 over 1. So is this table proportional? Which means, are all of these ratios equivalent?
Yes.
Yes. So this is proportional. Now, what comes into mind is, how did they create this table? They actually created this table. They just didn't list some numbers up there. They actually, there's a pattern every single time to create. Do you guys, anybody see the pattern, what you're doing to get from x to y?
Times 2.
Times 2. What do you notice about our equations? Times 2. So you're saying 2 times our x is equal to our what value? Our y. Now, that's how you find the equation. This actually, your coefficient on your, you know what a coefficient is, right?
Yes.
On your x term is the actual common ratio. Whatever that, if it is proportional. Can you make an equation if it's not proportional? You can, but not today. That's next year. Okay? I'm only going to take you guys as far as direct variation. If we have time, we'll do some more linear, but this is how far I'm going to get you this year. If we have extra time, I'll obviously take you further. So, let's try, you turn it over to the other side. Let's go to the back side here. Okay, flip it back over. Okay, flip it back over. You should see this table. You guys agree?
Yeah.
Now, first thing I want you guys to do is label your x and y. Do you guys know which variable is x to y in a horizontal table? Now, the vertical is on the back side. These x and y's are not labeled. Anybody know? Anna?
No.
Y would be days.
Nope.
No.
Y would be
This is x. This is y. Okay, so first label your x and y's. And if you notice, in the directions, when you start to find the ratio, which of these values in the table can you not read? And read the first paragraph? Which one are you not supposed to include? Alex?
0, 0.
0, 0. Okay? So you don't use that. So what could be our first ratio? Remember, we want y over y to x. Give me the first ratio off the table. Y, so we're talking number of books to days. You guys agree with that? Isn't that a ratio? Okay. Nick, what's our first one? 4 to 1. Good. How about the second ratio? Sydney?
2 over 8.
What?
2 over 8.
Y to x. I know, that's why we're practicing putting it in the right order. Remember, ratio doesn't in order. It does require order, so be careful with that. All right, how about the third ratio from the table? Harrison?
12 to 3.
12 to 3. So all of these, you guys agree, are y to x, y to x, y to x. Everyone good?
Mm-hmm.
Now, over here, obviously, what am I asking you to do? Simplify them all. 4 to 1, simplified is what? 4. 8 to 2, 4. 12 to 3, 4. Good. Now, if you notice, is this proportional?
Yeah.
Yes, it is, because all of these are the same. So, yes, it is. Now, I want you to practice something. What's our equation?
Oh.
Elizabeth? Yeah, or y is equal to 4x. Very good. So if it's proportional, I just want you to practice, writing the equation. Why? Because it's going to help you in the near future. Alex?
If you want it y to x and it's x over y in the beginning, couldn't you just put the table and rewrite it? So
Don't do that.
just so you're writing it that way.
No, just take it from the table y to x, y to x, y to x. Leave the table alone. That's what I would do. If you want to do that, Alex, good, but I'm saying it's not going to be a good scenario when you do that. All right, so second table. Nick?
How do you establish what was x and
I did from the beginning, Nick.
I know, but how do you know which
Right here. These are my x's. These are my y's.
That's what I mean. Like, how do you know?
Because you can't have.
From the table.
Is it just top and bottom?
Yeah, the top is always your X. Okay? Now, Nick, if it was a vertical table like this, X is always on the left-hand side. X always comes first. Think about, doesn't X come in the alphabet first? X, Y, Z, right? X. So X, left to right, in a vertical table is always on the left because it comes first. And then if it's on the top, sorry, I'm going the wrong way. If it's in a horizontal, isn't the top first, and then you work your way down. So X always is on the top. Okay? So, good question, Nick. Sorry, I misunderstood you the first time. So now, Nick, try this. Table 2. Which one's our X? Which variable is our X? Days or hours? Days. So here's, some kids would do this at the end. So they could see Y over X, Y over X. What's the ratio from this table? What's hours to days? Tommy?
4 to 1.
4 to 1. Another ratio. Greta? 6 to 2. Third ratio. Somebody I haven't heard from. Max, give me another ratio. 9 to 3. And let's simplify all this. 4 to 1 is 4, 3, 3. No. Can we write an equation? No. So is this proportional?
No.
So you guys think you can handle those?
Yeah.
Tables?
What ones do we do?
You finish the front and back of this. So you have 2 more to go here. And you have the tables left on the back. Is that good?
Yeah.
On this page? And then we'll hit graphs tomorrow, or do you guys want to do graphs? Graphs are actually 2 minutes. We could get this going. We could get done with it this week.
Let's do this.
Let's
Graphs
do it.
today.
Let's do it.
Let's do this. No, let's do this. We got this. Yes.
Right here, I want
Let's
you to
do it.
graph.
Do this.
Complain. I keep going. Graph these points on the coordinate plane.
What points?
Number 1. Graph them. Is this graph proportional?
Yes.
How can you prove that to me? What did we do in the last sheet that you could use in this sheet to help you determine that? Sam?
Well, so the first ratio is 1 to 5. Yeah,
1 to what?
1 to 2.
1 to 2?
And then the second ratio is 2 to 5.
2 to 4, you mean?
Yeah.
2 to 4. And then what's the third one?
4 to 8.
What do you notice about all those ratios?
1
What are they all equal to?
2.
Huh?
1/2.
1/2. So if these are all common ratios, which means that this table is proportional, which means this graph is also what? Proportional. So yes. Now let me tell you. I'm going to show you. First of all, I want you to ask yourself, where does this graph start? Okay, so first of all, for a proportional graph to work, for you guys to identify a proportional graph, it must, ready? Contact the origin. That's called the origin right here. That's the origin. On a coordinate plane, that's where you originate. Every time you start to graph, your pencil always goes back to that 0, 0 spot.
So like for
Okay.
number 4.
Hang on. Okay, it also, what do you also know about this line?
Straight.
It's straight. How else can you describe it? When a line goes like this, it's going up.
Increase.
Starts with a D. Instead of vertical, horizontal, think about the other.
Diagonal.
There you go. It's a straight, diagonal line. Now, you see how we wrote this number 1? Guess what? If you see this at all, you can just say C number 1. You don't have to write this again. You don't have to keep writing the same. There's 3 things to be a proportional graph. It must touch the origin. Okay? It must be straight, diagonal line. Okay? That's the cheat. Instead of having to do the ratios like that, remember how we did the ratios? But now, do you have to do the ratios anymore? No. Look at the back. Turn this paper over. Look at the back. Look at graph A. Is graph A proportional?
No.
So put NP if it's not proportional.
Right.
NP not proportional.
Oh.
Okay? Look at B. Is it proportional?
Yes.
Yes, just put a P. Is that cool? How about letter C, graph C?
No.
No. Do you see how quick this is?
Yeah.
You see why you could do this in 30 seconds. You see I didn't want to waste a whole day on that when we know we could use this to interpret graphs? Anna?
It says there are 2 things to look for in a proportional relationship.
Right here.
That's 3 things.
Straight diagonal line is one thing. And it has to contact the origin.
What about graph K and graph L? They say proportional.
I want you to create your own proportional graph,
Okay.
and I want you to be creative of a graph that's not proportional.
What about H?
What?
What about it?
Is it straight diagonal line? Yes. No, it's not.
It has a bend in it.
Oh, that's still
The
technically.
corner
It's
is down.
upside down V.
But I mean, all the lines are.
So, this is your homework. I want you to finish your tables on both sides, and I want you to finish the 3 graphs on the front side of this, and make sure that, the back side, both sides of these worksheets should be done for tomorrow. Okay? The graph worksheet, all you're doing is plotting the points, connecting them, and telling me if it's proportional or not. Okay? So remember, graphs must start at the origin. It must be straight, diagonal line. Okay? Is there a confusion on homework? Both sides of both sheets must be complete for tomorrow. We'll be ready to rock and roll. One of my favorite topics of the whole year is this.
Really?
This is the only, this is part of this is at least a function family. My function, what's one thing I missed in not teaching Algebra 1 this year? I taught it last year. Yeah.
If it's a no for proportional with the graph, you just write no C number 1.
Yes.
Okay.
Yep. Yeah, don't have to write number 1 those things again, Caleb, because you're just repeating yourself. And, if you keep repeating yourself, it just gets kind of crazy. Okay? So, Meg?
What's my home?